Student, this is your next experiment. The aim of the experiment is to design and the study of closed loop gain from non-inverting amplifier using 741 operational amplifier. Okay. The apparatus equipped for this experiment is breadboard, IC741, resistance 1K, digital storage oscilloscope, which is in short form it is called DSO, function generator, probes, connecting wire and power supply. Okay. So see here, this is called IC741. From the node side, here one node is here. From the this is pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, 6, 7, 8. Okay, this is IC741. Okay, see here. Pin number 1 is used for offset null, pin number 2 is inverting terminal, pin number 3 is used for non-inverting, pin number 4 and pin number 7 is used for negative VCC and positive VCC, pin number 5 is offset null, 6 is used for output and 8 is not connected. Okay. So this is the circuit diagram of non-inverting amplifier here. From pin number 2, which is inverting terminal, one resistance 1K is connected to the ground and another resistance, which is feedback resistance, connected to pin number 6 from pin number 2. Okay, both resistance RF feedback resistance is 1K and the input resistance is 1K, and because it is non-inverting, so we have to apply the input in the pin number 3. We have applied V in, which is sinusoidal signal in pin number 3. Pin number 7 is used for positive VCC, pin number 4 is used for negative VCC, and we will get output at pin number 6. The gain formula of this non-inverting amplifier is AV equal to 1 plus RF by R1, and the voltage output is equal to V in bracket 1 plus RF by R1. Let's say we will apply 2 volt as an input, and resistance is already we know that feedback resistance is 1K and the output resistance is input resistance is 1K. So 1 plus 1, 2 into 2, 4. Okay. If we apply 2 volt as an input, then we have to get that 4 volt as a output. Okay. So this is the expected waveform for non-inverting amplifier. This is the sine wave which we have to apply from input side. Then in the output side we will get same sine wave as in phase output in the output side. Okay. So for the observation table, input side and output side. Now I am going to connect the circuit. So as per the circuit, see here, I will connect as per the circuit. First of all, this is IC741. In the IC741 from pin number 2, one resistance is connected to the pin number 6, and from pin number 2 one resistance is connected to the pin number which is connected to the ground. Okay. So before starting the experiment, I will explain two devices. See here, this is called DSO, digital storage oscilloscope, where we will get the output waveform. Also we will get the input waveform. Okay. And here, this is the function generator. Okay, the purpose of function generator is we have to apply the sine wave from this function generator. Okay, first of all we have to fix this frequency at the 50 Hz by varying this knob. Okay, or you can vary the you can click this button. Okay, after that we have to convert this function. Here it is written as TRI. TRI means triangular. This function button is used to change the function. So we have to apply the sine wave. So this is square wave, sine wave. Okay, DC triangular sine wave. Okay, now come back to the circuit. I am going to connect the circuit. First of all, these are connected. Now this resistance is connected to ground. Okay, this is connected to the ground. Now in the power supply, this one is used for positive VCC, this one is used for negative VCC, and common is used for ground. So positive VCC should be connected to the pin number 7, and the negative VCC connected to the pin number 4. Pin number 4, and the common is connected to here. It is used for ground purpose. Okay, now I am connect these probes as a input. This probes is coming from this function generator. Okay, this is used as a input. Okay, it is connected to the pin number 3. Okay, also we have connected another probe to the pin number 3 to get the input in the DSO. Okay, so one probe is connected to the pin number 6 for output. Okay, now we have to ground this all another side of probe to the here. Okay, now I am going to turn on this power supply. To make sure that this, click on this terminal B and make sure this voltage is in 12 volt. Okay, now see here, by auto scaling it, we will get the output. Okay, this one is output and this one is input. Okay, input is sine wave, and also in phase that these are the in phase, so we will get the output in sine wave. Okay, this one sine wave. Now we have to measure the value of input side. Okay, for measuring purpose we have to click that measure button and display on this for output side. Wait a second. First select the channel which one? Channel 3 is used for input. Okay, channel 1, 2, 3 is used for input. Here in input, Vmax equal to 1.36 volt, Vmin equal to minus 1.64 volt. Negative terminal is for negative side. So VPP is almost 2.96 volt, and frequency is 50 hertz. These are the input. Okay, for this case our output will be in near between 6 volt or 5.78 volt. Okay, now coming back to channel number 1. Okay, in the channel number 1 here, see here VPP is 5.84, almost 6 volt. There is some error, but it is almost close to the 6 volt. As we are getting twice, gain is 2, so input is 2 multiple of output is 2 multiple of input. Okay, see here in the output side, Vmax equal to 2.56 volt, Vmin minus 3.28 volt, VPP is 5.84, volt and frequency is almost 50 hertz. Okay, this is the whole procedure of non-inverting amplifier.